You know, the Performance Tour show wouldn't be possible without our wonderful sponsors. So I'd like to take this opportunity to thank Tricentis and QA Consultants for supporting the performance testing and engineering community. I am on a quest. I want to find out how to make software and hardware perform at their peak. I want to know how to make applications faster, better, and more efficient. And while I'm at it, I want to have a little fun. Don't think I can do it? Just watch me. I'm Scott Moore, and this is the Performance Tour. Hi everyone, this is Scott Moore, and it's time for another episode of the Performance Tour. This time, we're focused on network performance. You know, that is one piece that is probably the dirtiest part of your round trip of your application, and we need to investigate that because the end user experience will be greatly different on any day, any place that's different, any time, or whatever the conditions are, even weather. I mean, it's amazing. Today we're going to talk about LAN, WAN, mobile, wireless. We've got it all on this episode of the Performance Tour. I'm here with Tony Fortunato of the technology firm. Tony, I'm sorry that we couldn't do this in person in Canada in the winter. Sorry we had to do this virtually, but welcome to the show. I still wanted to have a chance to pick your brain about network performance because I know that you've actually built your own internet service provider from scratch. So that sounds like you'd have to have a lot of network knowledge to do that, number one. Can you tell me the story behind building that out?
Sure. About 25 years ago, I moved out to a rural area from downtown Toronto. And we had nothing. Even dial-up was sketchy at best. So I tried the traditional satellite type of technology at the time, super expensive, super high latency, not very, I'm going to say usable for a lot of things I do. So I went ahead, talked to the local ham radio guys, because there's literally a tower across the street from me up on a foothill. And the folks there were pretty cool about everything, and they wanted internet. And I said, hey, how about I get a wireless link from the closest town where they have high-speed internet, we'll relay it to this tower and we'll have internet. And I'll give you guys free internet so you don't pay me, I don't have to pay rent for the tower. And they said, that's awesome, let's do it. So I got all the gear, 5 modems, got an antenna, 900 megahertz solution at that time, topped out at about 1.2 meg, which 25 years ago was screaming. Set all that jazz up, went across the road with my internal antenna, put it in my window, bang, I had internet. I was flying. Gave the ham guy couple of radios. He went back to his place about, 2 miles down the road, put him in his window because it's 900 megahertz, right? So you can go through almost anything. Bang, came right up. He was happy as can be. He told his neighbors, they told their neighbors. And I don't know, within 6 months, we probably went from me and 3 guys to over 100 and change users. So it quickly got out of hand. All they wanted was internet. They didn't want to build a company. So from there, it just went like wildfire because everybody here needed internet. The farms are becoming automated, and the cows have RFID tags on their ears and all that kind of jazz. So everybody needed high-speed internet for whatever reason. So it quickly got out of hand. And then I went from 1 tower to 3 towers to 6. And then from there, the local utility company approached me. They wanted to do the same thing. And the vendor told them, why don't you just talk to Tony? He's already got this all up and running. So then they ended up partnering with me, and then so on and so on. Long story short, the guy who helped me from day one started his own internet company. So I kind of do a lot of the architecture stuff. Of course, he does a lot of the stuff too. He's highly technical on the server side and network side. So now he's providing the infrastructure. I'm doing more of the consulting and design and troubleshooting stuff every once in a while when he needs it. And there you go, all done.
Wow. So what do you think was the biggest lesson that you learned from building this out?
The problem is, I don't want to sound so cliche about it, but the clients had no idea of what their kids were doing. They had no idea of the impact when you run a torrent, or at the time Skype, or whatever you're running at the time that chews up a whole bunch of little packets on a wireless network. It's never about the bandwidth, it's about the time. So a lot of little packets or a lot of little interrupts will chew up a lot of time, and everybody gets negatively impacted. And that's the issue. And that's, I try to explain that to people. It's kind of like going shopping with your 5-year-old kids in tow. They're constantly being interrupted. Where are they now? What are they doing? Dad, mom, and it takes you a lot longer to do anything. So that's the issue I kept coming up against, was people didn't know what was going on in their homes. They didn't understand that, with very little bandwidth, they could really cause a lot of problems, and so on and so on. So educating the client was part of the issue. And then at the local community center, I would have sessions for all the users to explain the network at a high level, to explain what's good, what's not good. Please don't have your kids leave their torrents running 7/24. Please don't just leave YouTube on 7/24. And the analogy is, in my garage, all my tools aren't on just because, right? Scott, all your instruments aren't powered on and your amp isn't on just because. You go and turn it on when you need it, right? So I had to get people to break that habit, because that's what they're used to with their TVs and their radios. Just leave it on all the time. Who cares, right?
Yeah, but what about those people who decide not to comply and they're not very good network neighbors? Do you still have a way of controlling the traffic and prioritizing the network traffic?
Yeah, this is where I was forced to learn some scripting. And in college, I learned about JCL, assembler, COBOL, BASIC, C language, all that kind of jazz. But I had to adapt and find a solution to prioritize traffic. So I wrote Perl scripts that went and polled all the radios, not for bandwidth, but for packets, packet rate, and the number of TCP and UDP connections being used by that client. If they exceeded a threshold, then I would choke down their radio for 30 minutes. And then I would get an email alert, and then we could contact them and say, hey guys, I don't know what's going on at your place, but there's something funky going on with your traffic. You might want to look at it. And the thresholds were baselined with my usage. So I know what Netflix did. I know what YouTube did. I knew what all the legitimate apps do. But then I also baseline things like torrent clients, or at the time Kazaa, and all those kinds of peer-to-peer sharing apps that were really, really chatty, even when they weren't doing anything. So, I had to get all that under my belt, write some Perl scripts, and then I wrote my own network management solution, basically.
Well, those sound like some huge tasks, and it gives people that are normally users of the network kind of a glimpse into the other side of what the ISPs actually have to deal with, because I think we still have to deal with those lessons today. So, Tony, I really appreciate it. Thank you for being on the Performance Tour.
Yeah, no problem. Thanks.
Great interview with Tony Fortunato about LAN connectivity and him building an ISP. Great stuff. But what about mobile connectivity? Mobile is probably more important than ever, and I have a lot of questions about that. And that takes me to our next interview. Okay, I'm here with Peter West of West Networks. Welcome to the Performance Tour show. Appreciate you being here.
Thank you for having me.
So we're talking about networks, and specifically right now we're talking about mobile networks and mobile experience. Why don't you tell our audience who you are and what West Networks does?
My name is Peter West with West Networks, and I am a senior architect there. So I help companies create reliable internet where otherwise they might have trouble getting it. Police departments, fire departments, and a lot of really big enterprises that we can't really talk about on the show, but we have
companies where you have to have connectivity. Wherever you go, even if you're out in the woods somewhere, you have to get internet.
Exactly. And so what we do is we use bonding technology. So we aggregate internet connections, and that's really the only way to do it. If you have your cell phone and you're out there, most people, I always tell people that when the internet works, it works for everyone, right? You have your hotspot, you're connected, good. You're connected to the internet, you're having a good time, and it's not a big deal. It's when it doesn't work. That's when the problem is. It's when you're trying to stream a 1080p stream or a 4K stream and you're sucking up 1 hour of Verizon's time and they go, no. We're not gonna give you an hour of dedicated 1080p bandwidth. And so that's where our bonding technology comes into play, because we can aggregate multiple SIM cards, multiple internet connections from multiple vendors like AT&T and T-Mobile and Verizon, and combine their sharing of bandwidth to allow you to have a reliable, high-speed connection everywhere you go.
Now, how I found out about West Networks was I go on the Performance Tour, and I need that connectivity, and of course, I'm all about performance, right? So when I found out that you could bond these technologies, I bought this from Peter. So why don't you explain a little bit about what this does specifically?
This is our baby Speed Fusion case.
So this is the lowest.
So this is our Transit Duo powered Speed Fusion case. So it's a dual cellular 4G LTE-A. What that means is, and the LTE is important because you have LTE and then LTEA. LTEA means I'm actually combining more than one frequency together per modem. So this router has 2 modems that can connect to 2 different carriers at the same time, but each modem can connect to 2 bands at the same time, giving him 4 bands or 4 frequencies of internet at the exact same time. And then we aggregate those together using what's called SpeedFusion Cloud from Peplink. And that gives us the bonding and the throughput in a small package with a battery and a power supply and a nice Pelican case for mobility.
So I have AT&T and I have T-Mobile in here with those cards, but I also use Verizon. So I have a data plan with Verizon as well. And there's a way that I can pair that with this, even if it's not on this machine, right?
Correct. So this router and all of our Max routers have what's called Wi-Fi WAN, which means not only do they have integrated cellular connectivity, they also have an Ethernet port for like connecting to a Nighthawk or another cellular router, or you can Wi-Fi it to a hotspot like your cell phone. So we have Wi-Fi LAN and WAN, and then we have Ethernet WAN and LAN. So you can connect it actually to 4 sources total, 2 integrated, 1 Ethernet and 1 Wi-Fi.
All right, so what would happen if you had one of these? And I always say that the fastest transaction is the one you never have to make. So what if we could reduce the amount of calls to the internet that I'm making as I'm using this as a hotspot wherever I'm at? Maybe I add caching technologies. I have my own CDN, my own proxy, my own Pi-hole where I'm blocking all these ads and things like that. Would that give me way better performance than just this standalone? Or I would think it would, right?
You would, right? But prior to, let's say, 2020 with the advent of TLS 1.3, that was possible. Now with TLS 1.3, they're blocking the header information, so content caching isn't as powerful as it used to be. So the more companies that upgrade their SSL certificates, the security negotiation of the app and the client, the less visibility a router or an ISP has to that session, which means it makes it much harder to see what's happening, which means you can't cache it as easily.
The big question I know everybody's going to have that talks to me is, Scott, you're talking about networks, you're talking about mobile, talking about wireless. Is 5G going to finally solve the performance problem that we didn't get from LTE? That is this now everybody's going to be, gigabit to their phone everywhere that they go. I mean, what is 5G realistically going to give us?
Well, AT&T just did it. They sunsetted 3G. So now what they're doing is they're opening up these frequencies that were 3G bands that were only getting 1.5 meg of throughput, and we're going to replace those with 5G bands. And those low frequency, older signals are now going to get a refreshed technology that's going to increase throughput, and it's going to make rural users have faster internet. You're not going to be seeing multi-gigabit. You're going to be seeing multi-100 megabit.
Got it.
But it's going to increase the availability of bandwidth for most people in the country, and it's going to be awesome.
And the thing I'm also thinking is 5G is still a shared resource, and it is still the dirtiest piece of your
correct
the transaction.
So that's why the bonding still matters, because it's still shared. You're still sharing bandwidth on a tower. You still have congestion. You still have use cases where you're not getting 500 megabits of throughput. That same idea with my 5G on my AT&T getting 8 megs. Just because it says 5G doesn't mean you're going to get high throughput. And so what's important is that we have diversity so that we can increase the chance that we get that throughput. Does that make sense?
Yeah, it does. Absolutely. So before we go, you've seen my case, but we haven't shown you his case. So let's talk about the next level up. If you were a company, a critical, like a healthcare company or something, and you need something that's way better than this, explain what this monstrosity is.
Well, this is our MBX, and it's a modular router. So it can be 4G or 5G. You just unscrew these 2 screws, pop it off, pop in a new module, and you have the new technology. So it's an upgradable modular router that allows you to go from one technology to the next. And so as ultra wideband becomes more popular, if Peplink puts a ultra wideband modem in here, we could actually get ultra wideband performance on this router. I want to make a statement. It's actually, yeah, we have a lot of business customers that use these, but we have a lot of residential customers too. Work from home has created a huge demand for reliable internet, Zoom calls, and making sure that when you're on a sales call with a customer, you don't have jitter, you don't have latency, you don't have the little
You have to make the best presentation
you want the
possible.
best presentation possible. And so I've sold more of these to consumers in the last year and a half than I've ever sold any other router at all to consumers.
Wow.
And the reason is because they see a demand for connectivity. They're out, they're in their mobile RV, their Sprinter, these new Sprinters out there. I mean that market's just blowing up, right? You get a Sprinter van, and
I would like to have one if anyone wants to sponsor me.
Me too. Him first though. But they'll take the Sprinter vans, they'll put these 5G MBXs on there, and then they're getting internet like they were at their office.
That's right. Yeah.
And so it is more expensive. It's not as portable and convenient, but when you're talking about mission critical internet or connectivity out in the world or out in the field, we've seen a huge demand for that. But mostly it's healthcare and first responders that buy this technology. And you are right about that.
And the difference between this is I've got 2 SIM cards in here with 2 providers and so much throughput.
Yep.
What's the differences?
This one's 4.
Okay.
So I've got 4 SIM cards and then I'm expandable to 9.
Wow.
You're expandable to 4. I'm expandable to 9.
Those can all be different providers.
All be different providers. So this has 4 built-in modems, 2 USB modems, and then 3 Ethernet modems.
And how much throughput? How much
3 and 2
bandwidth?
That's 8. No, 9. That's 9. Sorry, cut that out. And it supports 500 megs of bonded throughput.
And all this is bonded together, working as one big giant pipe.
We had a company in Texas, or a county in Texas, that needed to spin up a call center in a day to be able to fill. They just couldn't field the calls coming in. And so they rented an empty building that had no infrastructure. And they called me and said, we need internet for 200 phones tomorrow. And so I grabbed an MBX, flew out to Texas to set it up there, plugged in their network switch, and lit up 200 phones so they could power their response building.
Wow, that's amazing. All right, so I want to give some people some context as to how he got to where he is today. Talk a little bit about how you got started and how you got this patent for some things that because a lot of people think, well, if you're using stuff like this, it's really expensive. It's going to cost millions of dollars, and we want to pump large amounts of data through these networks, and it's going to be impossible. Talk about how you've been able to put a lot of data through smaller networks.
Yeah. So I started actually doing monitoring for environmental ecological stuff, and we actually back in 2008 got a patent on transmitting images for special projects. But in 2011, I started working I was asked by Jerry McLarty of LSU Health. There's actually a Jerry McLarty grant where we actually give away one of these kits every year in his honor.
Oh, okay.
So we started working with Jerry McLarty at LSU Healthcare to transmit live DICOM to mobile mammography images back to a PACS server so that they could do real-time readings, radiology readings of patients. So what would happen is he'd go out to the field, serving underprivileged communities, get a scan, but then he'd have to finish their trip, drive back to the hospital, plug in the PACS, upload it, read it, and then a lot of times they would never find those people again. Oh. So they would say, hey, we need to schedule a follow-up meeting, and they would never see that person again. And so what they wanted to do was get their hospital electronic medical records, get the capturing of the people, transmit those in real time for review, and that way in the event that they needed to reschedule, that person was still reachable. And so he said this is crucial capability to be able to transmit these images in real time. And so I worked with Jerry for 6 months playing around with the bigger enterprise bonding routers, because we didn't have this back then. Mm-hmm. And we actually built this in the back of his truck using a whole bunch of different parts. And I took a picture of it, sent it to Peplink. But the power that comes from the ability to aggregate SIM cards gave us the ability to transmit real-time X-ray images back to a PACS server for healthcare. And the technology has evolved to meet, and now 5G comes into place, and now we're talking more bandwidth, more opportunity. And I don't know if you want to steal this image for later, but we're doing an RV, so talking about RVs, we're actually doing an RV trade show next Saturday, and I'm not plugging my trade show.
Go ahead.
But we actually took, my artist took the AT&T, T-Mobile, and Verizon coverage maps and overlaid them. And we have with Peplink, it's AT&T, T-Mobile, and Verizon coverage map.
Right.
And it's like everywhere. everywhere's covered. I mean, there isn't a place on the country that's not covered, except for some really, really rural areas in the desert regions.
Where my parents live. I can tell you. That's why I bought this. No, anyway, it's a long story. But initially, when you were pushing these large amounts of data, you said petabytes of data. This was over a 3G network.
3G
this was
and
not
4G.
4G.
We were using terabytes a month, petabytes of data total, over 3G and 4G connections back before this ever started.
So it can be done, and you don't have to have the latest, greatest, whatever, but you just have to have somebody that knows what they're doing.
We have a client right now running 10 terabytes a month.
That's crazy.
Yeah.
Well, it's not crazy if you know what you're doing. But okay, so here's the thing. I have this crazy idea about cruise ships, all right? Because I live in Florida and I love going on cruises, and I haven't been able to go on one in a couple of years. But I was thinking, I've been on these cruises before, and you have these giant ships now with 6,000 people, including the people who work on it. Almost all of them are going to have a mobile device of some sort. They still expect connectivity as the ship's wandering around in the middle of the Caribbean Ocean. So you've got satellite technology, but they're still expecting to use Facebook and instant messaging and talking to people at home and blah, 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 surfing the web. How do you even make that stuff work?
Well, let's start with smaller ships, because Peplink is actually really popular in like yachts and things like that. So in smaller ships, the way that they do it is satellite's really expensive. And I'm going to get to your cruise ship, but I'd like to preface this with a yacht first. So the yachting community actually loves Peplink because of our multi-connectivity. We mentioned that your device can have 4 connections. Well, the Wi-Fi WAN, imagine that being the boatyard, right? They pull up to the dock and they can connect to the Wi-Fi at the shipyard. Then the cellular, as they pull away from land, they drop the Wi-Fi and they connect to cellular. Now remember, we have cellular antennas on the top of the mast. And so they can go 50 or 100 miles offshore, still connected to cellular. Once the cellular drops, it kicks into satellite. So our yachting community, they use Wi-Fi, cellular, satellite as they pull away from the technology, and the Peplink router keeps them connected. I'm not convincing any cruise ship to buy an HD4.
Right.
But my point though is, now cruise ships, they use satellite. They don't use the satellite that you and I use. They're going to use, so cellular uses bands. We talked about that earlier. And the more bands you have, the better throughput, and we're sharing bands.
Right.
When you buy Viasat, or you buy HughesNet, or you buy DirecTV satellite, you're buying a piece of time on a band that's being shared with everybody in your area. And that's how they can give you satellite for so affordable. That's how they can give you $49 a month or $300 a month satellite, because they're sharing a piece of a time on a single frequency with you. Big yacht companies, or even military or other institutions that need big data over satellite, can actually create satellite connections that are as reliable as fiber. And you do this by buying the whole band.
Okay.
So they're going to buy the whole frequency, and it's called dedicated frequency. Just like you have dedicated fiber, you can buy dedicated frequency. And their dedicated frequency is, and I don't know this, someone could maybe chat and comment on this, but I'm going to assume it's in the hundreds of thousands of dollars a month. Is going to be my guess. I don't know. I've never sold dedicated frequency before, but my guess is that is how they're able to provide 6,000 people with high-speed internet on a cruise ship out in the middle of nowhere.
Awesome. I wonder what it would be like if I had a cruise ship. This was an amazing conversation. I've learned a lot. I know our audience has learned a lot. Thank you so much, Peter, for being on the Performance Tour. You know what I feel like right now? I think we should go get some barbecue.
I love that idea.
Let's do it. I had a lot of feedback about my cousin Bubba, and apparently a lot of you want to hear about some of my other family members. Well, I can't forget about my cousin James. J-Mon, or as he's now known as J-Man, or J-Mon. That's right. You see, James several years ago decided that he wanted to move to Jamaica and live the Caribbean life. And J-Mon, as he's called now, he believes that people should be free, software should be free, and everything should be free. Everything should be free, man. He also likes performance testing as well. And he really likes JMeter.
Performance testers, listen to me. The commercial software world is a mess. Open source software is better than anything they got there. Listen, developers want to load test to see where performance slow. Developers got no budget. The boss man, he just said no. And when you got no money, then you got to innovate. You download a GitHub repo, no time to evaluate. Ha! JMeter's free. JMeter's free. It's how you load test if you're an SNET or SRE. What do they got? Analysis? Who cares? We never look at this. Run in the pipeline, we make the deadline. JMeter's free. It's okay with me. What do they got? A lot of style. We got some code that might compile. Each new release, defects increase. JMeter's free. Each little test here is not the best here, but JMeter's free. There was no sale here. Look how we fail here. We will holler to save $1, and it sucks here. We're out of luck, but JMeter's free. Ha 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 ha.
So that's my cousin J-Mon, and that's this episode of the Performance Tour. I hope you enjoyed it. And until next time, we'll see you out on the road. Software should be free. That's a horrible Jamaican accent. I'm going to get ridiculed.